Hello and welcome to AI 360. This is the second installment in our series where we take last week's happenings in research level AI and try to summarize them for you in an easily digestible format. First up, we have Facebook AI research proposing the unified transformer. Now, as we probably all know, transformers have led to a massive paradigm shift in AI and NLP. Recently, there's been growing research into multimodal transformers as well, such as with the VL-BERT or the Vision Language Pre-training Framework architecture. Now, FAIR, or Facebook AI Research, proposed the Multimodal Unified Transformer, UNIT for short, which is jointly trained on 7 different tasks across 8 different datasets. Some of these tasks include object detection, VQA, and natural language inference. At a very high level, the architecture consists of 2 transformer encoders and 1 transformer decoder. We have 1 transformer encoder for the image and 1 for the text, and as input, the transformer decoder takes in a task-specific encoding. Obviously, during the cross-multi-head attention step, it will receive the concatenation from the outputs of the image encoder and the text encoder. The authors show that we can achieve comparable performance to state-of-the-art task-specific models with a reduced set of parameters if we were to add up all the parameters for 7 different state-of-the-art task-specific models. Secondly, Sebastian Ruder has a new blog post, which is titled Recent Advances in Language Model Fine-tuning. He discusses how the transformer and BERT paradigm has evolved our notion of pre-training and fine-tuning, and provides great high-level and intuitive descriptions of adaptive, behavioral, parameter-efficient, and text-to-text fine-tuning, alongside some tips on how we can mitigate fine-tuning instabilities. If you want to read more, which I would highly recommend, check out the link, which you can find in our website. Thirdly, we have updates from OpenAI about DALL-E. Now, in case you missed it, DALL-E is a zero-shot text-to-image framework which OpenAI announced a couple of months ago. They announced this in the form of a blog post, but now their paper and part of their model has been released. And once again, if you want the links, find them on our website. They don't release the whole model. They just release the discrete variational autoencoder, and this can be found on their GitHub. Now, they don't actually plan to release the model in its entirety at all, and they're still considering whether they'll allow semi-open access through an API, similar to what's currently going on with GPT-3. However, the community have been quick to implement or have some implementations already, so check them out. And you can find these on our website. Fourthly, the father of deep learning, Geoffrey Hinton, proposes GLOM, or how to represent part-whole hierarchies in a neural network. Now, GLOM is a very conceptual architecture which discusses a method for representing an image as a tree-like hierarchy using a neural network. So when I say neural network, I mean we'll have one fixed weight neural network, and with multiple different images, we want to generate multiple different tree-like hierarchies for the objects inside the images. Now, Hinton claims that if GLOM can be made to work, as I said, it's just a conceptual architecture, but if it can be made to work, representations created by transformer vision language systems can have significantly improved interpretability. And finally, we have StudioGAN, which was introduced by Reddit user Minkowski. I hope I pronounced that right, Minkowski. Now, StudioGAN is an OpenTorch PyTorch library featuring state-of-the-art GAN models. It contains extensive GAN implementations which have been benchmarked on a wide variety of image datasets, and also includes pre-trained models such as the original DC-GAN, Big-GAN, and bringing us more up to the state-of-the-art Contra-GAN, which I believe was the author's own GAN implementation, alongside training tips for multi-GPU systems such as data distributed parallel, and many other implementation tricks to speed up training. So if you guys are doing GAN research at all, definitely check out this library. Once again, you can find the link and the original Reddit post on our website. To finish up, we have this week's recommended reads. These 3 that we see here at the bottom, I've already talked about slightly in the relevant sections, but we have Transformer is All You Need, multimodal multitask learning with a unified transformer. We have the zero-shot text-to-image generation paper, which is OpenAI's DALL-E, and how to represent part-whole hierarchies in a neural network, which is Hinton's GLOM. Last week, we had a paper presentation by Mubashara Akhtar, a first-year PhD student at King's College, where she presented 2 papers, both of which were under the umbrella of Progress Towards Natural Language Understanding. So visit our website if you're interested in NLU. Anyway, that's all from me, and I'll see you guys next week on the 8th of March.